equation. And to do that,
So you want me to solve this one for?
solve that for the point it crosses through on that.
No.
No.
I just want to make sure that I understood what you said. So you said to solve this one for,
I think
yes?
I'm really just trying to get this into words. So I'm going to say change it into slope-intercept form or point-slope form.
Slope-intercept form.
And that
Why?
way,
Why? In order to determine?
in order to determine its slope, so that you can find the slope of the other one.
Exactly. In order to find the slope.
It's
Okay, so let's,
lost it.
that's okay. So let's talk about it again. What I know about the unknown line, basically, is just this point. So I will think, since it's not the y-intercept, I'm immediately writing the point slope form. I immediately write under x1, 5, and under y1, -9. And I realize that the only thing that is in my way between myself and the solution is the slope. That's the only thing I don't have. But I know that two lines that are perpendicular have an established relationship between the two slopes. If I know the slope of the green line, indirectly I will determine the slope of the unknown line. So I can determine this from what I'm given, because I know that the two lines that are perpendicular if I know M1, I can determine M2. But I have to solve the equation for y. In this form, as I mentioned, this is the standard form. I can identify the slope. I can identify the y-intercept. I have to solve for y. I have to present the equation like this in the slope-intercept form. If I do, then I will be able to identify the slope. Once I know the slope of the green line, I will determine the slope of the orange line. Are you with me? I know it was a long sentence. I'm sorry. I try to keep things simple. Is this clear? Okay, so I need to solve this for y. How do I do it? I write 7y. X goes to the other side. -12 goes to the other side. And what do I write? So I write -x plus 12. Very good. Now, please do not write this. I'm gonna write it again. I know we have to divide by 7. Do not write this. This is not useful. Okay? Instead of writing that, I know I have to divide by 7 each and every term. I will say this divided by 7 is y. This divided by 7 is -1/7 x plus this divided by 7 is 12/7. This is more useful because now I can identify the slope of the green line. Can anyone give us, I'm going to call it M2. Can anyone give us the slope of the green line?
-1/7.
Do we all agree with -1/7? Knowing that the product has to equal -1 because they are perpendicular, can anyone give us the slope of the orange line? Let's call it M1. Other than Tom.
As always.
Not always.
Most.
Okay, M1 equals?
Positive.
Very good. Because 7 times -1/7 is -1. Perfect. So now I have all unknowns, and I'm ready to write the equation. I have the point, 5, -9. I have the slope, which is 7. All I have to do is just plug them in. So y minus -9 is y plus 9, and then 7, and then x minus 5. Yes, it's very nice. No fractions. I didn't mean to choose a problem with no fractions because I want you to see fractions too. But yes, I have to solve for y. I have to distribute 7, and then what do I do with 9? Subtract or move it to the other side. Very good. So then I have y equals 7x minus 35 and minus 9. And what do I get? Y equals 7x minus,
44.
that's it. 7x minus 44. Any questions for me? Any questions? Any questions? Okay, I think what I would like to do now is go back to a piecewise defined function and a difference quotient. Yes, yes. Yes, this is the equation of the line. Yes, I should have mentioned that, sorry. This is the equation of the line passing through the point 5 comma negative 9 and perpendicular to the given line. Thank you. So this is the equation of the line passing through 5 comma negative 9 and perpendicular to the given line, which is x plus 7, y minus 12. Sorry about that. Any questions? Okay, so yes, please, Alex, go ahead.
On the test, like, are you gonna ask us what the equation of the line is?
Yes.
Okay, so on the first problem that you did,
Yes.
put that in general form. Is that an answer, or do we have to put that in a slope intercept?
I always put in slope intercept form. I always solve for y.
Okay.
I recommend that, yes. Anything else? Very good question. Anything else? Can anyone make up a quadratic function for us so we can find its difference quotient? Other than Tom. Any quadratic function? Anyone?
F of x equals 1/2 x, 4 plus 10.
That's not quadratic.
No, it's not?
No.
Oh, quadratic.
Yes.
Okay, 1/2 x squared
Yes?
plus 2x minus 10.
Awesome. This is a quadratic function. We're asked to find the difference quotient. You do not have to remember the difference quotient formula. It is nice if you do, but you don't have to. It will be given to you. So here's the formula. F of x plus h minus f of x divided by h. Now, if you remember from last time, what did we say we have and what we don't have? Look at the difference quotient. How many pieces? If you look at this expression, how many pieces do you see? How many pieces do you see at the top?
2.
2. You see f of x plus h. And you see f of x. Good. How many pieces do we see in the denominator? Pieces or terms? 1. Very good. From 1, 2, 3 pieces, which one needs work? Is it number 1, is it number 2, or number 3? Number 1, of course. So we have to work on this first. We cannot just start putting it together yet. We have this piece, this is given to us, but we don't have f of x plus h. So let's take a look. Can anyone tell us what to write? Other than Tom.
I don't even know. So,
Yes, you do.
well, I can't not off the top of my head.
Let's look at the function, right? What does the function say? Here's what this function says to me. It, of course, that's what I said. So 1/2 the variable squared plus 2 times the variable minus 10. What is the variable now?
X plus h.
X plus h is the variable. Good. So then can anyone dictate?
I won't. Let's see.
I have to copy 1/2, and then what do I copy? Give it a shot. Yes? Awesome. Plus.
2x plus h.
in parentheses, and minus 10. Very good. Remember, we have an agreement on the first one. Please don't make a mistake and tell me what to write. I have to simplify it as much as I can. And then put all three pieces together. But this has to be simplified. I copy 1/2. What do I have in parentheses?
X squared plus H squared.
We have an agreement,
2xh.
2xh
H squared.
plus h squared. Very good. Here I can distribute, plus 2x plus 2h minus 10. Now, only now I distribute 1/2. And we'll ban Eddie from choosing because he put that 1/2 in there. I'm kidding. I'm kidding. I'm kidding. Why not? It's very good. This is the simplified form of this.
Sure doesn't look simplified.
That's as much as I can simplify.
I know, I'm joking.
That's okay. You are allowed. Now I can put all three pieces together. Instead of this, I will copy this. 1/2 x squared plus xh plus 1/2 h squared plus 2x plus 2h minus 10. I'm here now with minus in front of the function. What do I write next? How do I continue?
Just put in the function.
How do I write it? Just dictate.
Minus 1/2 x squared. I forget what the plus or minus 2x minus 10.
Very good. Done. And the denominator is h. Now remember the two things that have to happen. What is the first one? We mentioned this at the beginning of the class.
Get rid of
All terms without h must go away. Maybe some terms with h will go away, I don't know. But definitely those that do not have h must go away. So can you combine like terms and eliminate anything?
Yes, you can. Those the 2x there and the negative 2x there, and both 10s. Oh, and the 1/2 x squared.
As you see, all these are opposite terms. They add up to be 0. They add up to 0, right? So how many terms are left at the top?
3
Yes, 1, 2, 3. What do they have in common?
h.
Let's pull it out. When we pull out h from those three terms, what is left inside parentheses?
X plus 1/2 h plus 2.
Very good. X plus 1/2 h plus 2. What will happen next? The second thing that is mandatory to happen for any difference quotient for any function.
Get rid of h.
That's it. And the answer is x plus 1/2 h plus 2. As you see, the simplified form of the difference quotient still has h in it, but not this one. Good. I would like to graph a piecewise defined function, please. Let's choose a piecewise defined function. Do you allow me to make one up, or you want to choose from the book? I'll show you where they are. They are on page 252. Do I choose, or you want to choose, or I can make one up? The problems are 59 through 70. Okay, I'll make one up. Let's say f of x is negative 2x plus 4 for x less than or equal to 1. And let's say x plus 5 for x greater than 1. The question here is graph. This is a piecewise defined function. Defined in how many pieces? 2 pieces. Very good. A piecewise defined function. And we're asked to graph it. Whenever I'm given a function to graph, what is the first thing I determine? Always, for any function. And I'm going to ask you this in the next chapter, chapter 3, and I'm going to ask you the same thing in chapter 4.
In this case, 1.
In all cases, whenever I am trying to graph a function, in all cases, what is the first thing I do?
The number it's defined by.
Exactly, which is called?
I forget.
Domain.
Domain. That's all.
Domain is the first step. If I'm asked to graph a function by hand with a calculator in any way, shape, or form, I have to find its domain. That is the starting point.
Domain was all values in y or x.
I will ask about the range after we graph it.
Okay.
But right now, the domain is necessary. So please replace this with the interval notation for me, and replace this with the interval notation for me.
Negative infinity, comma, 1 bracket,
Awesome.
one, comma, infinity.
Very good. Now let's look at this and this. I know this is defined here. This is defined here, but I'm interested in the domain of f. I'm not interested in the domain of each piece. I'm interested in the domain of the entire function. So let's take a look. What will be the domain? By simply looking at these two, you will be able to identify the domain. Can anyone tell us what is the domain of this function?
All real numbers.
Yes, would you agree? Because we have everything between negative infinity and 1. We have 1. And everything between 1 and infinity. Yes, I completely agree with the domain for f being negative infinity to infinity. Then I will get the chart going. Now I'm going to ask which x value is absolutely crucial here. It must be in the chart even if you like it or not. Yes. Can anyone say again why? 1 has to be in the chart. Because it's the threshold. It's where the function changes from one to the other piece. And if you remember, when we graph one portion, we cannot extend it on the other side. So it's 2 different pieces and they never overlap. Very good. Now, the next step I recommend is this. See, under 1, we have a bracket facing left. I'm going to copy it right exactly underneath 1. Also under 1, I see a parenthesis facing right, touching because there is nothing missing. These 2 symbols are exactly underneath 1. Now I'm going to ask you something that is an overkill, and I hope you will bear with me though. Which of the 2 pieces is defined between negative infinity and 1?
Left.
Which one? I want to write it here.
Negative 2x.
Of course. Very good. Okay, you can say, well, you have them right here. True. But they may not be in the correct order. I just want to see them on my chart so I don't make a mistake. Which piece are we going to use for x values between 1 and infinity? I know it's an overkill and it's very clear now. It's that is a silly question. Yes, it is x plus 5. What type of functions are these? Because then I will know how many points I need.
Linear.
Linear functions. Very good. So let's plug in some values. So if we plug in 0, 0 should be in the chart. When you plug in 0, what do you get?
4.
Good. When you plug in 1, what do you get?
5. No. 2.
2.
2. And I write it right here inside the bracket. The left branch is done. Now I'm moving on to the right branch. Please plug in 1 in this function. And you should say,
6.
yes, but you should first, you're correct, but you should first say, no way, right? I'm not allowed to plug in 1 in this function because the equal symbol is here. I'm allowed to plug in 1 here and I have a bracket, but I'm not allowed to plug in 1 in here, correct? But I will, because if I don't, then I have to start from the number that is the closest, the real number that is closest to 1 on the right-hand side of 1. I don't know what that is.
Like you said last time, 0.9, infinite number.
But this one will
nines.
be 1.000000, so I have to plug it in. So you already told me 6. I write the 6 inside the parenthesis. And then let's choose another one. Let's say 2. What do I get with 2?
7.
That's it. This is more than enough. I shouldn't say more. This is enough. That's all we need. From left to right, which ordered pair will you plot first?
0, 4.
Here it is. The next ordered pair.
1, 2.
Is this a full point or an open point? Does it exist or it does not
It
exist?
exists, so it's full.
Very good. And it's done. I cannot do anything else to the left branch. This is completely done. It cannot be extended anywhere. Next ordered pair. Next in line is
1, 6.
perfect. So now I need to identify or establish whether this exists or it does not. If it exists, it's a full point. If it doesn't exist, it has to be an open point. If I'm not allowed to plug in 1, it cannot exist. If I'm allowed to plug in 1 in this branch, that it's a full point. So is it a full point or an open point? You agree? Very good. It cannot be closed. It cannot be a full point because
Then it wouldn't be a
it
function.
wouldn't be a function. Thank you very much. So then 2, 7. We cannot extend this branch to the right, and we cannot extend this branch to the left. This is it. So now I can ask the range of this function. Can anyone give us the range of this function? Do you all agree with 2 to infinity with the bracket? The lowest possible value is 2, and the largest possible value is infinity. Any questions? Any questions? A few more minutes. I'd like to review basic functions with you in preparation for the last section before the test. I like to write basic functions or call them basic functions. They're not really called basic functions in your book. I call them basic because from each category there will be the simplest possible function. So from the category of linear function or linear functions, can you give me the simplest possible linear function that exists?
Equals X.
That's it. There is no simpler linear equation or linear function than this one. Everything else is more sophisticated. And here's the graph. If you remember, it bisects the first and the third quadrants. So this is the line f of x equals x. Is this function symmetric, which means odd or even? Is it symmetric with respect to the y-axis by any chance, or is it symmetric with respect to the origin? Yes, very good. So this function is indeed odd. Perfect. Symmetric with respect to the origin. Perfect. From quadratic functions,
X squared plus X.
the simplest possible quadratic function. Can anyone give us the simplest possible? The simplest one. That's so complicated, I don't even want to think about it.
X squared.
That's it. That is the simplest possible quadratic function. There is no other quadratic function simpler than this. So let's take a look at the graph. Here's the graph of x squared. So this is f of x equals x squared. And what is this function symmetric? Is it odd or even?
Symmetric.
Yes, it is even function, which means symmetric with respect to the y-axis. Perfect. Next function, square root. What are we going to do with these? You're going to have to wait and see. We're just listing them to make sure the graphs their graphs are embedded in our memory. A square root function, the simplest possible square root.
Root of X.
Of course. Can anyone give us the domain of this function?
Well, every point up to, every point past 0,
Very good.
but not including it.
Yes. So the square root requires a positive number or 0 underneath. So therefore, x indeed must be greater than or equal to 0, which means the domain is 0 to infinity. Absolutely true. So here's the graph.
You can take the square root of 0. So
Yes. The square root of 0 is 0. Because 0 squared is 0. Yes.
0 to the power of 0 is undefined, even though it should be 1.
No.
Well, everything else to the power of
0,
is 1.
but this is 0 squared. We're not talking about 0 raised to 0.
Okay.
But you are right. You don't have to write this. I'm writing this for Tom. So 0 to the second power is 0. 0 to the first power is 0. But 0 raised to 0 is indeterminate, not undefined. You have to wait till Calc 1 for that. Okay, and other things. So you don't have to write this. So coming back, here's the graph of the square root. Can anyone tell us whether this function is symmetric, odd, even, or none of the above?
None.
Of course. Not symmetric. Which means it's not odd and it's not even. That's what we say, not symmetric. Cube root. Cube root. The simplest possible cube root, please.
Cube root of X.
That's it. There is nothing easier than this. Domain for the cube root. I'm going to give you a hint.
Technically all real numbers.
Not technically, but that's true. It's more than technically. Indeed. This function, in other words, I can apply the cube root to anything you want, but I cannot apply the square root to anything we want.
Yeah, funny thing about even and odd numbers.
Correct.
With powers and roots anyway.
Here's the graph of the cube root. This kind of resembles the square root, but there is this other piece because the function is defined everywhere. So this is f of x, which is the cube root of x. Odd, even, or none of the above? Very good. Symmetric with respect to the origin. Perfect. Last two more. And then we can stop. Absolute value. absolute value function. Can anyone give us the simplest possible absolute value function? Other than Tom. Thank you very much. Good. So what is the domain of the absolute value? Of course. No problem there whatsoever. And that is what type of function? How did we call it?
Symmetric.
Yes, it's a v function, yes. So f of x equals the absolute value of x, and the function is even. It's symmetric with respect to the y-axis. Last one. Which may or may not have been thoroughly studied before, but we will thoroughly study it again in chapter 3, is the rational function. We will add to this list more functions later. Can anyone give us the simplest possible rational function that you can think of?
1 over x.
That's it. Now you understand why I call these basic functions.
That's basic.
The
Basic
simplest,
ones that we
this exactly, the simplest possible function. Can anyone give us the domain, other than Tom, the domain of this function?
Negative infinity to infinity.
Careful. Ew, exactly, without 0. So the domain is negative infinity 0, union 0 to infinity. It cannot have 0 in the denominator. Very good. So now let's graph it. We can graph it with the calculator and so on and so forth, but I will give the graph right now, and then we'll discuss it again on Thursday. Here's the graph. So this is the graph of the simplest possible rational function. I'll explain in chapter 3 what these lines really represent for the function. For now, this is just a graph, and I would like to identify whether it's symmetric or not.
Symmetric.
Odd, very good. It's an odd function. It's symmetric with respect to the origin. Any questions?